In this video, I will show an object moving at the same speed without changing direction, a computer model of that object that shows my observations based on Newton's second law, and I will also compare the predicted position versus the observed position and discuss possible discrepancies. So the first thing that I will show is the object in motion. My object is just a standard basketball and it's moving across a flat surface. Now, as you can see, the ball moves across the surface, and I picked out 10 points. These 10 points are now put into a graph by Tracker and also put into a table by Tracker. These 10 points give me two values, my initial position and my initial velocity. My initial position is just the first point in the graph, which is 0.212 meters. Now, the initial velocity is calculated by the change in position over the change in time, which is calculated to be negative 0.056 meters per second. Now, given that information, I can now put it into Python code, which generates a predicted position for me using Newton's second law, which is shown here. Now, I also calculate for the mass, which is 0.62 kilograms. As I said, the initial position is 0.212 meters per second, and the ball's velocity is negative 0.056 meters per second. Now, when this is run, it gives a computer model as well as data points calculated by Python, which is then put into an Excel file, as you can see here. Now, in this Excel file, I have my change in times, and I also have my predicted positions and my observed positions, which are also shown in this chart here. Now, as you can see, the final predicted position and the final observed position are relatively close. Some possible discrepancies for that is the amount of data points I have. I only have 10 data points. It's possible that if I had more data points, the prediction would be a little bit more accurate. I also have my delta t. If my delta t was a little bit smaller, again, it'd be a little bit more accurate. That's it. Thank you.